Alright, so now we're going to be doing some practice problems, and these problems are going to be very similar to past ones that we've done. We're just going to be rewriting expressions. Alright, so we're just manipulating the way things look using our different formulas right here. So the first one we're going to do is the power reducing, and our instructions are going to be to rewrite the expression. And I do want you to write these instructions because on the test this is what you'll see. So rewrite the expression in an equivalent form with no powers greater than 1. And I'm going to give you 6 sine to the 4th x. Alright, so this is going to be fun. This is going to be quite a mess. So we've got a formula here for sine squared theta, and we can reduce the power to 1 by applying this formula. However, we have a sine to the 4th. So before we even get started, we can't actually do a substitution right now. We need to change this into 6 sine squared x times sine squared x. So now we can substitute. So we can use that identity. I'm just going to pull it up right here. And we're going to say 6 over 1, because we're going to have fractions involved, times 1 minus cosine of 2 theta over 2, times the same thing again, 1 minus cosine of 2 theta all over 2. And now that we've done that, the trig part's over. Now it's just a matter of algebraic manipulation. So I can see here that this 2 and 6 are going to reduce. I'm also going to go ahead and FOIL out these two quantities on top since they're being multiplied. So I'm going to have 3 over 1 times, and here I'm going to have 1 minus cosine of 2 theta minus another cosine of 2 theta plus a cosine squared of 2 theta. And that's all over 2. So now I'm just going to put this 3 on top and 2 on bottom over here together. Yes, I can do that because it's multiplication. So we've got 3 halves out front, and then all this nonsense together. 1 minus 2 cosine 2 theta plus cosine squared 2 theta. So what happened here was I just multiplied the 1 times 2 on bottom and brought it out front so that this numerator or denominator could be 1. So that's why there's no longer a denominator over here. I also combined my two like terms, my negative cosines of 2 theta, into one term. Keep in mind all this is right here are double angles. So we can't actually do anything with that 2 that's with the theta. Now, unfortunately, this says rewrite the expression with no powers greater than 1, and right here we actually have a power that's greater than 1, so we have to apply yet another power reducing formula. This time we're going to do the one for cosine. So this is going to be equal to, so we're kind of doing a problem within a problem, 3 halves times 1 minus 2 cosine of 2 theta. But instead of a cosine squared of 2 theta here, I'm going to use that formula, and it's going to be 1 plus cosine of 2 times 2 theta all over 2. Now I chose this problem on purpose because you can see here that, make note of this. This one's a squared in this step, cosine squared. And then down here, using the formula, we have cosine of 2 times 2 theta. Why did I do that? Well, in the formula, it says to take theta and you double the angle. So it goes from theta to 2 theta. Well, here we already had a 2 theta, so when we double the angle, it's going to be 4 theta. So I'm just following this pattern, doubling the angle. So since ours was already doubled, it's going to double again. So I'm going to highlight that just to make note of it, and just write over here that it doubled again. Now from here on out, there's just a bunch of algebra to do because all of our powers now are lower, are down to 1. So what I'm going to do is just clean this up a bit, and I'm going to rewrite this as 3/2 times 1 minus 2 cosine of 2 theta plus 1 plus cosine of 4 theta all over 2. And yeah, I know that this is kind of yucky looking. We've got a fraction out front and a fraction over here, but algebraically we can move it around a little bit more, but we're not going to because that's not what I'm worried about. What I'm worried about is doing what the problem asked. And there's nothing mathematically incorrect about this. So let's go ahead and do another example, this time with a half angle. So in this example, we're going to find the exact value of an expression. So find the exact value of sine of 15 degrees. Alright, so looking at our half angle formulas, here we've got our sine formula, and here's how we're going to use it. Sine of oh, okay, I got it. This one's really weird to think about. Sine of 15 degrees is the same as sine of 30 degrees divided by 2. And that's going to fit one of our half angle identities. So what I had to do, my thinking process, and a thought bubble over here, is think of what divided by 2 gives me 15 degrees. Okay, because this number that we end up with on top is going to be the alpha that we use in our equation. So it's helpful to us that our alpha is 30 because when we go over here, we can find cosine of 30. So now I just apply that identity. And I'm going to say, well, sine of 30 over 20 is equal to plus or minus the square root of 1 minus cosine of 30 over 2. Now this plus or minus here, which one it is, it can only be one of them. Which one it is depends on your original angle. So notice my angle here was in the first quadrant, so I know that sine's positive in the first quadrant. That means it's only positive. So whenever you're pick the sign, remember all students take calculus, and that'll help you to determine which sign you need to use. So from here on out, now again, it's just algebra, so the trig part's over. Now we're just going to do the square root, 1 minus cosine of 30. Cosine of 30 is the square root of 3 over 2. If you don't believe me, draw your triangle. Here's 30 degrees. It's 1 square root of 3 and 2. So it is indeed square root of 3 over 2. And more algebra work. Yucky, yucky, yucky. Okay. So this, on top, we have to get common denominators. So we're going to have 2 over 2 minus the square root of 3 over 2, all divided by 2. Now I'm going to combine like terms in the numerator. So 2 minus the square root of 3 over 2. And I'm also at the same time going to do stay switch switch. So my bottom fraction of 2 over 1, I'm going to flip to 1 over 2. And that's going to equal the square root of 2 minus the square root of 3 all over 4. And we can square root the bottom and top individually. And our final answer is the square root of 2 minus the square root of 3 all over 2. Phew! These are yucky algebra problems, okay? But keep in mind, if you do the trig part correctly, I'm going to give you a 3. I'm being nice. In college trig, they will not do that. But the algebra, I want you guys to be good at. But that's how you get an A, is being able to do the algebra work. A 3 is a C, so a 3 is being able to do the trig work. Okay? So now let's talk about warm-up problems. Okay? I want you to do page 586, and I want you to try to do number 36. That's all I want you to do. It's going to be one that's very much like this first example. The second example, we'll do ones like that in class. Okay? So good luck, and I'll see you tomorrow.